What if there is a giant planet or something massive beyond Neptune? In April 2024, researchers Konstantin Batygin and Mike Brown from Caltech California Institute of Technology presented new evidence suggesting the existence of a ninth planet in our solar system. This finding adds to previous research indicating that a massive unseen planet may be influencing the orbits of distant objects beyond Neptune. After creating simulations, they argued that a group of little bodies beyond Neptune bunched together due to Planet 9's gravitational influence. Since then, researchers think that a larger, more distant object is gravitationally pulling them into this pattern. Interestingly, this is how Neptune was discovered. The orbit of Uranus was irregular, leading scientists to investigate if there was another mass in the same area of the solar system. They eventually found Neptune. Therefore, it is believed that there is an object much larger than Pluto very far away in the solar system. This planet would be the size of 5 Earths and would take between 10,000 and 20,000 years to complete just one full orbit around the Sun, a distance of 400 to 800 astronomical units, about 20 times further from our Sun on average than Neptune. It's so far that would be beyond the Kuiper Belt. The Kuiper Belt lies beyond Neptune's orbit, around 30 astronomical units from the Sun. It is a vast ring-shaped field of icy rocks. This is where Pluto, Arrokoth, and countless other small objects reside in the cold and dark. These are known as Kuiper Belt objects. The Kuiper Belt contains tens of thousands of known objects and likely millions more that haven't been discovered yet. So if there are many objects beyond Neptune's orbit, even large ones like Pluto, why can't any of them be classified as planets, while this supposed Planet 9 could be? Let's use Pluto as an example. According to the International Astronomical Union, Pluto hasn't been classified as a planet anymore since 2006 because of 3 things. For an object to be considered a planet in our solar system, it must meet 3 criteria. 1. It must orbit the Sun. 2. It must be spherical in shape, meaning it has enough gravitational force to pull itself into a nearly round shape. And 3. It must have cleared its orbit of other debris. This means that the object is gravitationally dominant in its orbital zone, and there are no other bodies of comparable size besides its natural satellites or those under its gravitational influence. Pluto meets the first 2 criteria, but fails the third. As Pluto is located in the Kuiper Belt, it shares its orbital zone with other objects, many small icy bodies and rocks, some even larger than Pluto. Mike Brown, one of the researchers engaged in studying the existence of Planet 9, was considered one of the most responsible for putting Pluto in the category of a dwarf planet. He even wrote a book with this curious title, How I Killed Pluto and Why It Had It Coming, which shows what happened during the process of changing Pluto's category in astronomy. The discovery of Eris, a dwarf planet 27% more massive than Pluto, was crucial in this changing. If Pluto was a planet, then Eris and potentially other similar objects in the Kuiper Belt should be considered planets too. That would have meant the solar system had many more planets, possibly dozens, as more large icy bodies were discovered. Thus, the need arose to create a formal definition of what should be considered a planet. Neither Pluto nor Eris were included in this definition. On the other hand, the proposed Planet 9, which scientists have suggested exists, would meet all 3 criteria, including the third one that Pluto lacks to be considered a planet. An orbit cleared of other debris thanks to its estimated path far beyond the Kuiper Belt in a region where few objects exist. The existence of Planet 9, despite its extreme distance, could help explain the unusual orbits of 2 extreme trans-Neptunian objects, bodies even farther from the Sun than typical Kuiper Belt objects. The first of these objects, Sedna, was discovered in 2003, one of the most distant objects in the solar system. Unlike standard Kuiper Belt objects, which get gravitationally kicked out by Neptune and then returned back to it, Sedna never gets very close to Neptune. A second object like Sedna, known as 2012 VP 113, was announced in 2014. The presence of Planet 9 in its proposed orbit naturally produces Sedna-like objects by taking a standard Kuiper belt object and slowly pulling it away into an orbit less connected to Neptune. If Planet 9 is located so far away in the solar system, what caused it to end up there? Scientists suggest that Planet 9 probably formed near Uranus and Neptune, but then passed too close to one of the larger planets, likely Saturn, and was subsequently ejected to the outer part of the solar system, where it has been lurking ever since. In addition to this hypothesis, there is another idea that could also explain the origin of Planet 9, and that's one of the most intriguing classes of astronomical objects. The rogue planet is used as an alternative to explain how Planet 9 could appear and stay in the solar system. A rogue planet is an interstellar object of planetary mass, which is not gravitationally bound to any star. Rogue planets may originate from planetary systems in which they are formed and later ejected, or they can also form on their own outside a planetary system. The Milky Way alone may have billions to trillions of rogue planets. Planet 9, being a rogue planet, could have traveled for many years from another star and eventually being captured by our Sun. But what if it isn't actually a planet? Some researchers proposed that Planet 9 might not be a planet at all, but rather a black hole. After all, planets aren't the only objects capable of exerting gravitational influence. Other possibilities include a compact clump of dark matter or even a primordial black hole. While stellar black holes with masses at least 3 times that of the Sun and supermassive black holes millions of times larger are well known, primordial black holes are a different case. They've never been observed directly, but are theorized to have formed in the first seconds after the Big Bang from dense fluctuations in energy and matter. These alternatives are incredibly hard to detect. Objects like black holes don't reflect light, which makes them extremely challenging to observe using current telescopes. The conclusion is clear: something is gravitationally influencing distant objects, but we still don't know what it is. If it's a black hole, it would likely collide with or disrupt asteroids in the outer solar system, pulling in their material through gravitational tides. This process could produce faint light flares too dim to detect now, but potentially visible with observations from the Legacy Survey of Space and Time at the Vera Rubin Observatory in Chile. Even if it turns out not to be a planet, the search itself could lead to new discoveries about the solar system. That alone is exciting, especially with today's advanced technology. There are many possibilities ahead. If you want to know more or receive more updates and discoveries, subscribe to the channel. See you next time.